Hi, we're going to talk about another lab today. It's emission spectra. Now this is purely qualitative. You're going to take pure ion solutions like a sodium solution. So maybe you've dissolved like a sodium nitrate in water, or you've made just a solution of potassium chloride. You're going to take these individual solutions of group 1 and group 2 ions, okay? And you're going to test them to get their emission spectra. Now let me give you an example. That's an example of emission spectra right there. This is sodium, and you can see that the sodium, it has one line at 589 meters. That's like a fingerprint. That's like a fingerprint. You take any sodium ion, that's the emission spectra that it's going to give. Now, what you do is you take those individual solutions, so just sodium, just potassium, just magnesium, get their emission spectra. So you have the single emission spectra, and then you're going to be given some mixture, some unknown mixture, and your professor is going to ask you, what are the ions in this solution? So all you have to do is take that emission spectra, you're going to get all these lines, and you go back and compare it to yours. Let me give you an example of this. So here would be two examples of mixtures. Look at all of the emission spectra inside of there. This would be one mixture, this would be a second mixture, and you can see all the different little lines indicating different ions. Now, some ions will have multiple peaks, okay? They're going to have multiple wavelengths. Sodium's an easy one because it just has one. Now, there's a practicality technique in this. You're going to have a fiber optic, okay, that goes like this. And you're going to position the Bunsen burner so the fiber optic can read the color of the flame. That's really what it's reading when it says wavelength. It's reading the color of the flame. So position, I'll go like this, position your fiber optic so that it can read the color of the flame. Now the way that we're going to get the color of the flame is we're going to have right there that air intake. We are going to vaporize this solution so that it goes up through the air intake and then is burned, so that the atoms are excited, electrons move to the excited state, move back down to ground state, and they emit light that we're going to see as the color of the flame. Let me show you something kind of cool. So this right here is an example of those pretty colors of emission spectra. It's just simply taking different salts. This would be a copper ion. You burn it, the electrons intake the energy, jump to an excited energy level, come back down to ground state, their original energy level where they existed, and then they release the energy in the form of light. And for copper, this is going to be green. It produces that green color. So we need to put energy into our solutions, into our ions, which is by burning them, so that the color of the flame changes to whatever that particular ion is. Like if I did copper, you will get a really pretty green flame out of here. So a couple of practical things. You're going to be using nichrome wire. There you go. There's the nichrome wire. And you'll need 2 petri dishes. So have 1 petri dish just with distilled water, because you'll want to clean this out. You're going to have this intake several different ions throughout the course of the lab. Oops, excuse me. So here you have it. You're going to have distilled water in here. Heat up the nichrome wire. It's got to get hot enough that when it touches the water, it vaporizes it. So I'm heating this up, hot, it gets red hot. You put it here in the water, it goes tss. Do you like my sound effect? It vaporizes, and the water is going to be sucked in through this air tank and go through your Bunsen burner, and it's going to clean it out. Okay, it's going to clean it out. Now you're going to have 1 nichrome wire just for the water. Now you get, let's say, our sodium. I've dissolved a sodium nitrate in here. The nitrate is not going to produce a color. It's only going to be our group 1 and group 2 ions that will produce the color that we're using. Remember, this is all sitting on the bench, okay? I'm not by any means touching this. This is all sitting on the bench. I'm just showing you this. Okay, so I put just a small amount of solution of sodium nitrate in here. Then I get my other nichrome wire that's been labeled for sodium, heat it up till it turns red hot. It doesn't take very long. And then you hit this. It's going to intake that sodium solution, and it's going to come out a brilliant yellow color, because sodium is like this yellow orangish color, a really, really bright yellow color. Here's the deal though, the fiber optic has to read it. It depends on your system. The system that we used at the university where I worked, it took 2 people to do it. One person would do the splattering and one person would push read, that it would have to record it. It wasn't constantly reading. You had to tell the fiber optic when to read. So it took 2 people, one to splatter and the other one to push the button for the fiber optic right here to read that color. So your lab TA, your teacher, professor, they'll show you how the fiber optic will read the color. Okay, so I would do at least 2 trials on that. And then you do the whole thing again. I'm going to swap out, get the different Petri dish, get my other nichrome wire, clean it with water. So every time you splatter and clean it with water, and then you go to the next ion. And you'll probably have like 5 ions, 5 to 7 ions, that you're going to get the individual spectra. Let me go back to that sodium. You're going to get the individual emission spectra for each of those ions. Then your professor will give you a mixture. And so you'll do the mixture, and that's when you see all of these wavelengths in a mixture of a spectra. And then it's pretty cool. All you do is you line up the individual spectra you have, and you look at this and you go, oh, in fact, look at this one. In the second sample, there it is, it says 589. Looking at that, I go, oh, it matches. We must have sodium in that sample. And that's how you do emission spectra. Now, I am going to post for you underneath this video a couple of reminders. The C equals lambda times nu and E equals H times nu. Great follow-up questions are, they tell you the energy of the wavelengths, and you have to find the wavelengths right here. So it'll tell you energy, you find wavelengths, or you get this emission spectra. You know the wavelength, and so then they ask for energy. And they could ask for energy in, remember this is joules per photon, or they could press you and ask you for the energy in kilojoules per mole. So if you need a refresher on that, I'm going to include 2 videos for the follow-up questions that could be asked on this lab, all dealing with the 2 formulas for light and energy. So there you have it. It's a fun lab, all qualitative. You can't quantify it. You can't determine how many ions, what's the concentration of sodium. You're just identifying what's in the solution. Oh, I see there's a sodium and a strontium inside the solution. So it's all qualitative, just identifying what's there. You can't quantify it and give the amount of ions. Okay, there you have it. Have a lot of fun. If you need more help, please check out my playlist under labs, or with this, the playlist is under atomic, or as under light. Sorry, the playlist is light. All right, have a really good day. Lean think. Thanks. Sorry, thanks.